the talk bubble closed loop, and I think I'm gonna run it with a transistor because right now I'm running it via transistor and we're gaining on the cap bank, and it's running. It's not. I tried a Hall effect sensor. I think the trigger coil is gonna work the best. Just gotta hook the piezo's up now, and we're good there. I think.
There's the piezos.
I think the more energy that gets in this cap bank, the faster that wheel's gonna go, hopefully. Awesome. I'm just taking it all in right now. I've been working on that for set up like 3 different ways. It looks like it's slowing down actually. So let me give it another spin. Let me get. Oh, that was too close. Can you hear that?
Oh, the core sticking out. That's what's up.
Yeah. That's all right if the core's sticking out.
Oh, okay.
It's just got to make sure it's far enough away so that it doesn't attach. But here, let me try pushing that back in a little bit. There we go. Now I need to get it just a little bit closer. Maybe a little bit farther back. Okay, here we go. We get it. Because the cap bank's still going up, it's hard to tell whether it's taking because the rotor spins very well. I think it's good. I think we're good. Now this is the dual drive bifilar coil. I have both strands of 20 gauge and a strand of 32 gauge in series, and then I have one 32 gauge strand for the trigger. Now what would make this run even better is if I had a halogen bulb.
What does the halogen bulb do?
Offers resistance, and it bridges the emitter and the collector.
On the transistor?
Yeah.
Got it.
So, I'm gonna look over here real fast. Yep, we got one. Nice. Haha. This is the halogen bulb. 2 little prongs.
Mm-hmm.
Alright, so we take 2 clips.
Magleved.
Yes, sir.
And drop us a like if you like maglev.
Thank you.
And this is tedious work, folks, for sure. With the clips and the wires.
Better than soldering, in my opinion.
And the hand tremors.
Yeah, maybe not the outcome, but the actual process for me is better.
Mm-hmm. Hey everybody, welcome to the channel. Thank you for dropping in. Like and subscribe. Take a look at our question. Let us know what you think.
Because I asked a question earlier today, can you do BEMF and shorting a coil at the same time? And one person chimed in, as far as I know, and said no. And I'm like, yeah, that's right, because you have BEMF diode and you have the shorting diode. Shorting basically means you connect the ass end to the front end and you've shorted your coil.
Okay.
put in a BEMF diode means it goes all the way through, and then it's forced to come all the way back. Okay, it's going to take the path of least resistance every time. So shorting the coil is going to win every time. It'd be awesome. I mean, like if you oversaturate the coil to the point where both pathways get flooded, then I guess that's a win, but that would probably be a lot of electricity.
Yeah, for sure. For sure. Hey everybody, welcome to the channel. Thank you for dropping in. Like and subscribe. Let us know if you have any comments, questions, anything. This is a sweet rotor. We combine art and pulse motors here. Let's get a nice look at that. And you can explain the setup here.
Yeah. Right now, I tried to do a lot of different setups. I tried, as you can see, the Hall effect sensor. Right now, I'm working with the trigger coil, and we got like 1,660 turns of 20 gauge and 830 turns of 32 gauge in series, and then we have 830 turns of 32 gauge for a trigger. And how would I explain that in terms of mass?
Ooh.
This coil weighs about 2.8 pounds without the core.
Okay.
No, I think more like 2.3 without the core. I can't take the core out. We could weigh it with the core in it if you want. I got a nice Weight Watcher scale, and it'll weigh it to the tenth of an ounce.
Straight up. Thank you for the like. Welcome in. Drasco. Wanagi. Or Wanagi. How do you pronounce that? And thank you for the compliment. We appreciate that. Like and subscribe if you love pulse motor content.
Huh. I'm wondering, what do you think? Should I take the 32 gauge strand out and just have it be 20 gauge? And then add the 32 gauge strand to the trigger and have it be 1,660 and 1,660. And then it won't take as much to spin to hit the trigger. Because I don't think it's triggering. It doesn't look like it's triggering.
Right. And then it slows down a little bit.
Yeah, and then that little bit of slowdown is going to be a lot of slowdown. But there is only 4.5 volts in the cap bank currently. You know what I'm going to do? We're going to give it the BEMF test.
Oh yeah, it's happening. There's the reading upside down, but there it is. That is a
How's the rotor
bunch.
looking? You going faster?
I think it is.
Alright, I think we're good then. Hell yeah. Alright, we're up to 8 volts in the cap bank now.
So you're wanting to create a system that charges up and uses. Is that, I mean, yeah. Hold on. But from the sun.
Yeah. You see over here we have power supplies. I want to replace all the power supplies with solar panels that will charge and power everything.
And then you want to be able to charge the unit faster that it's being spent.
That's the only way it'll work.
Okay.
That's why you need the solar panels, because you need at least a power supply. You can't do it with batteries.
Right.
You can do it with like a 48 volt battery and these 12 volt batteries. You can do it like that. But I don't suggest doing it like that. I just suggest having more amperage, having like a power supply or a solar panel.
Right.
And not really exceeding the voltage too much.
And then is it going to be relays? You were mentioning that, or is there another mechanism?
Well, when I figured out that I can charge a battery and spin from that same battery at the same time, the relay became less important.
Because, you know, I think people get things.
The relays are just supposed to, if I don't have to switch the switch, then I don't need the relays.
So now, what's the difference between converting to solar and what we're saying? Is there any difference?
There's a huge difference, and the difference is I'm not in that field. I'm in the field of having fun. I'm not in the field of, changing the world.
I love it, man. And what got you started making all this fun? What started it when we were kids?
Magnets on the fridge.
That's right.
And then when I would get them real close together, they'd either flip and come together, or they'd come together. But you'd have to force them to stay in repel mode.
And then most of this energy-specific stuff has come directly from the community, right?
Yes. Oh yeah, man. I didn't start out doing any of this pulse motor stuff. I didn't even know what to call this thing when I first made it. They're like, what do you call it? And I'm like, they're like, it's a pulse motor. I'm like, really?
We've been self-learning and self-taught since that moment, and we thank the community for their input, your input.
But I think I'm very, very much misunderstood in the community, and I think people think that I'm in it to, create over unity and, do all. That's fun to try, but that's not my goal. I end up, doing something very bad to myself. If that was
Well,
my
I
goal.
mean, I think that's obvious because you run 20 different experiments in one live. You're not just focusing on one thing.
That's so true. And I mean, if we can get this trigger strand to fire, and keep firing, looks like it'll be cheap to run.
Yeah, and then literally every time you move a clip, it's a new schematic. So
That's true.
we need an AI to be able to do that because it's so rapid.
I could make a schematic, but honestly, the one over there under the glue, right there.
Yeah, here, right here.
Is basically what's going on the table, give or take a couple of changes.
Sorry about that, guys. And that's so the mess of wires, batteries, switches, coils, and rotors is that.
The talk bubble is basically, and then
They do that.
yeah, that's the talk bubble closed loop right there.
Like and subscribe. Thank you for coming in. Let us know if you have any questions. Check out our question.
And what it does, this is the closed loop over here. And what it does is it runs on the cap bank. There's multiple cap banks in this build. And then one cap bank force charges another cap bank, but the thing that's force charging it is hooked to the wall. So ultimately it'll never die.
Because it's plugged into the socket.
Right. The battery will always be charged up, and this will never stop if I don't want it to, because it's plugged into the wall. And I'm willing to change that and make it solar, but I'm being real about it.
Cost wise.
No, it's not even about cost. It's about the fact that you have to have power to make these things work. They don't run themselves. So I need solar, or I need a battery that lasts for 1,000 years.
I think those are coming, bro.
I do. I believe it.
Mm-hmm. And there's stuff like nuclear diamond battery theory,
Nice.
which is insane.
Sorry, I get passionate about the battery thing because, well, I mean, I'm really excited that I can supercharge my whole thing here from the wall to the pulse motor over here through this battery. I can charge this battery and charge this cat bank at the same time, just from being plugged into the wall.
Thank you, Creative Solutions.
I didn't used to think that was possible until I watched it happen myself.
Right. You've been on quite a journey, dude.
I mean, I was told specifically that you can't charge and spin from a battery at the same time. I'm like, BS, I just did it. All you gotta do is be putting more in than you're taking out, and you will be going up on both fronts, you know? So I don't know about this.
Hey everybody, welcome to the channel. Thank you for dropping in. This is Papa Bale, and we're working with a closed loop talk bubble
Yep.
build today.
Talk bubble closed loop.
And this is it. This is the schematic hand drawn, but we do rapid experimentation here, so it's kind of, it was that once.
It's a stem cell of what it is, because the basic cell is the same for everybody. You know what I'm saying? The basic cell is right there on the paper.
I get what you're saying, and then you manifest from it.
And then and then all the specifics stem from that.
And the community gets involved. And we...
So, yeah, that's awesome.
Yeah.
And I think that I might have to do that trigger thing that I said I was going to do.
Thank you for the like.
Make the trigger longer and make the drive only 20 instead of adding that 32 strand into the drive. We're going to add it to the trigger.
So you can see he's very focused on this coil right here. And the cat bank and the clips in between.
I wonder if we take that out altogether.
And then, yeah, for your information, the schematic would change when he does that. And you're
So
taking the core out.
Yeah.
So that's why I think an AI, if it's able to correctly identify, I know we'll have to set up a system where it can read the connections better, but it could definitely produce schematics at a rapid pace. What's up, Yanni?
Hey, Yanni. Whoa. I think I'm going to leave it where it's at.
Okay.
I'm not going to mess with it right now. It's halfway out. And I just want to get this rotor or this coil closer to the... Yeah, let's see what happens now.
Thank you for the like. Appreciate you guys. Yeah, I like watching this one spin. Those are some vibrant colors. Try not to get the glare.
I can feel it pulsing, but it might just be the core.
Yeah, this is one of the originals. He was using wood. What discs? Wooden discs, and he just glued a bunch of them together to get the thickness of it to where the big magnets would hold it.
I'm trying to think. Solo?
For the wood discs?
Yeah.
And the acrylic discs?
Yeah.
Okay. Yeah.
He had a nice 1/4-inch center hole. That's where the 1/4-inch stuff started.
Here's a
From the
acrylic
1/4-inch
one.
center holes and the 1/4 inches in the pegboard.
And our base table. This is the original table?
No,
No, this is
second table.
second table. He built it We need to.
We had brown pegboard first.
We're gonna get another one. We're gonna hopefully have a friend build one.
Oh, is that Ernie?
Chris can do it. Nice flywheel effect too, says Yanni.
Yeah, I got these magnets that I can screw in. They got the countersink holes into the side of this, and then I can make it all even. Maybe get, like 12 magnets on the outside.
Hey everybody, thanks for dropping in. Welcome to the channel. Like and subscribe. Let us know if you have any questions. Check out our question. Let us know your thoughts. Welcome back,
Welcome.
Mr. Asa. Thank you for the like. Check this one out. This was one of the original ones. And he does a lot of art too. Oh, I can still see the green dude, man.
Oh, yeah?
Yeah.
Yeah.
There's the head and the legs. That's funny.
Mm.
But these are some real strong magnet clusters, creating some good data on one of the first rotors. So it's a cool moment. And how far we've come since this one. And him specifically, he's done most of the work. I just hold the camera and talk.
What would I do without you?
Yeah. Yes, it is. Oh, I got what you mean, like a parade. And I'll go look at all the comments on it here in a little bit and read them out. And Papa Bale gave a nice explanation of why he thinks shorting the coil over others would win, but we're open to opinions.
Swap this for this. And we gotta put this one on that one, and we should be good to go.
And then we'll just pretend that an AI Jarvis created a new schematic and we posted it. All right. Well, what is this plugged into? I need the power over here when you're done with that.
All right, here, let me get it.
Nice work. Glad I didn't yank on that. Thank you, sir.
Well, that looks like it's working.
All right.
Maybe too much.
And what changes did you make?
Well, I made the trigger longer, and I made the drive without 32 in it. So both of those changes, just by changing the one strand.
Rock and roll.
All right. Now, let's turn this meter on so we gauge what we're doing here. Now we'll BEMF it.
Look at how fast that's going, guys.
That's a BEMF off of the 26 gauge coil.
And that's just from making contact right there.
I had to put one of the fat diodes on there because the skinny ones kept burning up. Yeah, that definitely looks like it's working. But it looks like we're spending.
Oh yeah, it was going down when you took it off. I'll show that again.
Oh yeah, that's supposed to, you're right. I just jolted it, so it'll go down for a while.
At a
Hopefully
steady, it looks like a steady rate.
Yeah, it should stop though. But this is the first time I've run it with,
And I think like soon we'll just be able to point a camera with an AI voice thing on it and see if it can read the rate. So we don't need all that sophisticated equipment.
yeah, that, woo! It's working. It's working! It's like my favorite part of that Star Wars movie when the little Anakin's like, it's working!
Yeah. Hey everybody, welcome to the channel. Thank you for dropping in. This is Papa Bale. We are working with our talk bubble closed loop system this evening, making some rapid experimentation and having some fun. Like and subscribe. Let us know if you got any pulse motor projects at home, and check out the question if you are familiar with the context.
So we may need to set up a relay just to have a timed charge of the battery.
It's alive!
Because you can see the sparks flying.
Let me see if I can zoom in. Oh, next time. Yep, he's like Anakin working. Like, and he gave us one of these. Yeah.
It's working. God, it's so awesome. Look at how much better that runs on a trigger coil than it was on my homemade switch. Even though the switch was awesome, I could hook all those up in parallel without a problem with the switch, but it wouldn't run like that. No way.
That is beautiful. And then what is this doing over here? We got this going too.
All right, this is Halbach arrayed, so all north, south. There's 4 magnets in the rotor. This is the coil that's powering that rotor over there. It's hooked up to this battery right here. This battery is being charged constantly by this coil. Speaking of that, it's been running pretty much all day. I'm going to turn it down. It gets up to about 12.7, and then it kind of mellows out, and then it can run after that point and not really charge any more than that. So I wasn't really worried about it, but we're going to give it a little rest. So this battery is constantly charging. It's always ready to go. This battery is hooked to this coil and that power supply. And that power supply and this coil charge this battery rapidly. Charge it very rapidly. And then this coil discharges from this battery at a slower rate. So this battery and that whole system charge at the same time due to this battery's capability to charge and dispense at the same time. It happens. It's cool. You just got to be putting more in than you're putting out. You
Right.
can't do it closed looped. You can do it talk bubble closed loops, but you can't do it closed looped because you're on the same battery and you're never ever going to be having the power circle around to be more than a closed loop. I haven't seen it. I've heard lots of theory, but I need, what do you call it? Scat?
Ray Doan said, nice Bendini.
True that.
That style motors are most efficient, and I believe it's the key to the next level.
I agree. It's very efficient. This one, however, is not the most efficient.
Hey, leave the screen alone. He's stuck in it.
Oh man.
Oh, he just got down, I think.
Is he good?
Yep. Okay. Kitty got his claws in the screen. We need those screens, man.
So with the Halbach array, there is a certain way that you spin this and a certain way that you don't spin it. I mean, we can spin it the don't way, and I'll show you what happens.
Yep. It
That's
stops.
That's the don't way.
That's counterclockwise. This is clockwise. And it goes. And it goes very nicely.
So smooth. And then this coil, the way I have it set up is on 12 volts. Okay, this coil will not push 12 volts on its own. So it needs this coil, and well, this coil and this coil are linked together like this. Okay? So I can put 12.7 volts in, it'll go up to 700 milliamps, but we're charging this battery, and we're also pacing this coil to pump the 12 volts out. And when I BEMF it, it's like a direct connection to the battery.
So Ray said, I wonder why it stops when you spin it counterclockwise.
Because they're all polarized. The coils are polarized.
Polarized coils.
They're wrapped in a traction phase. So
An intentional thing.
yeah, it's very intentional.
Yep.
What you do is you roll it all the way regular, and then you take one turn to get all the way back. And you roll it regular, one turn to get back. Regular, one turn to get back. So one layer is only being wrapped in one direction. If you get what I'm saying.
He said, oh, okay, I got it.
And I'm lucky, actually, because these were all rolled at different time frames.
Yep.
So I'm lucky that they're all in sync. Because I had a coil that wasn't in sync, and when I would spin the rotor one way, it would react negatively or poorly.
Yep.
It would run poorly. So yeah, I'm glad they're all in sync now. That's good. I love this, man. It's moving.
Yeah, this is cool, man. I'm happy to see this. Did you come and get this out of the storage the other day?
Yes, sir.
Yeah.
I do want to show you this 24 volt system that I have kicking over here too.
Another power supply.
So we got our DC bench, goes up to 31 volts.
$1,500 views. Thank you guys so much. We appreciate you guys. Like and subscribe. We have a large library of awesome pulse motor content. Let us know if you have any questions.
Yeah, it's not catching. I'll get it though. We'll get this. Yeah.
Thanks, Johnny. Thanks for dropping in.
There we go. We got it.
Yeah. You can tell my bad when
Oh, you gotta come around this side.
the amps go up. Milliamps in this case.
All right, get this wave real quick.
Wow.
Oh yeah. And that's with the 10 millimeter shaft. So that's still got a lot of vibration with 10 millimeters. But I was thinking for a maglev that I was gonna maybe short this coil and try to create a north field or a south field. I need to make sure which field is in the middle here. Yeah, south field. And then it goes all the way up to the tip here. So we want a south field. Repel it up, try and lift it up a little bit. But that's going to take me focus and concentration, and
Yeah, time.
we'll get it. Because I'm trying to make a maglev that'll work. The donut ferrite magnets are not large enough. The diameter isn't big enough to work, so they don't work.
Mr. Asa says, what an improvement since the last time I watched.
Thank you. I love that thing, man. It's moving so smoothly. That is so good. We are spending though, for sure. It is not, and it's on, so it's not force charging the way it would. With my switch, it would charge while it's running without the BEMF, but. Sweet. But who cares, right? You can charge it whenever you want. So what if it's spending? Who cares?
Right.
Because it's a talk bubble closed loop. It's not just a closed loop. You can charge it whenever you want to. You know, seriously, this is it right here. You charge it with this, and you can either hook that up to a coil on a different rotor, or you can hook it up to a battery and just straight up and, you know, flip that switch, turn that battery on whenever you need it.
So you're saying the mixture of capacitors and batteries is essential.
I would assume.
Okay, I don't think we see that in
And then maybe
most
solar.
things.
You need a power source that's not a battery.
And I wonder.
I do anyway.
I wonder if it would be applicable in EVs, cat battery mixture.
Yeah.
Mhm.
I think having the chemical, different chemical in and out for the energy is key for it to expand at all. Oh, he just wants the door open. Pigs? The baby.
Oh, yeah, he's being weird. There he goes. He's built like an ox, that one. That kitten.
Yeah, man. Because you see his shoulders, he's like this. He's like a British bulldog.
Yeah.
It's freaking crazy. so cool. And I'm glad I finally got it hooked up via trigger coil.
Yeah.
It's running smooth.
Yeah, and that is balanced. It's not wobbling at all.
And it's off to the side of the table. So I'm
Yeah,
like,
and-
yeah, that's really good.
Yeah, dude, this is nice.
See, this red bobbin coil is a trifilar coil, and I have the other strand and the trigger hooked up to that SSG right there. So what I want to do is I want to get another power supply and hook it up to the SSG and have that output hooked up also to this cap bank.
2,000 views. Thank you guys very much. We appreciate you. Hit the like button, subscribe. Let us know if you have any comments.
Awesome. Okay, so yeah, hook that up. See, that's the thing. I'm out of power supplies. I got batteries lying all over the place, but they don't really work that well. They don't allow for the proper amount of experimentation. So I don't know. I need a deep cell battery or something like that. You know, deep cycle.
Right.
That would probably work better for what I do.
I've just heard there's new sodium batteries coming out of China that multiplied the cycles by a lot. And they're sodium, so they're cheaper.
Heck yeah.
Yeah.
That's what I'm talking about. Cheap. Well, inexpensive, not cheap. There's a difference between inexpensive and cheap.
Mr. Asa says you need the right strength and size.
Oh.
What she said was a joke. That was a good one, man. Oh, God.
Right on, dude.
Yeah. Welcome to the channel, everybody. Thanks for coming in. I see 70 people watching right now. Like and subscribe. We got a ton of pulse motor content on the channel. Let us know if you have any questions.
All right, I'm going to juice up the battery real quick.
Sorry.
Good. Turn on the power supply here. It's a 12 volt car battery jumper. This right here. And then I'm going to turn on the signal generator at 300 hertz. So not only is it being pulsed, this coil by the rotor, it's got 300 hertz being pumped into it by the signal generator, which increases the rate of generation by like 80%, 90%.
Okay. So a signal generator is an important ingredient in the recipe.
Yeah, I would consider it either that or PWM,
Which is?
something that provides the pulse without the frequency. The pulse without the sine wave, the
Okay.
arbitrary waveform.
All
It
right.
doesn't necessarily have that. What it does not have is the multiple. I think it only has a sine wave or a square wave. I'm not sure which one it is. Where is it? I got it one lying around here somewhere. Oh, here it is. It's PWM right here.
Yeah. All right. I remember that guy, and you had it
You-
screwed in.
Yeah.
Mm-hmm. Okay. So caps, batteries, PWMs, and signal generators.
Yeah, if you're only looking to pulse your trigger, you just need a PWM. If you're looking to do stuff with like Tesla coils, you're gonna need your arbitrary waveform.
And Bryce says it's pulse width modulation.
Thank you, sir. Pulse width modulator.
Yes.
A PWM is a pulse width modulator. So this coil has a 26 gauge trigger, and that's what fires this whole thing off. I gotta show you one more time how delicate this is. How little it takes to set this off. So I'll turn it up to 12. And then I'll just... See that?
Yeah.
That took no effort whatsoever. And this coil was on. Usually, well, that's when I was running it at 3 volts. And this coil wasn't hooked up. It wouldn't start up if this coil was on, because it slows it down, but it's not slowing it down now. It's running at 12. It's perfectly fine.
Hey everybody, welcome to the channel. Thank you for dropping in. Like and subscribe. Let us know if you have any comments.
All right, so we got the super cap bank over here.
Super.
And it's we charge that up with the talk bubble closed loop. So the talk bubble is right here, the little comma comes out of the talk bubble. So you have power on the other side, right? That you have control over, that you can turn on, you can turn off. You don't always have to have it on. Okay.
It's just making contact with the diode. And this is the result. That's pretty fast, bro.
Yeah, that's a super cap. That's 500 farad, 6 caps.
This guy, the blue one.
That is super fast for that much capacitance. Yeah. And then once you get it juiced up, this thing will spin really fast. So what I want to do is I want to get it juiced up to 15 volts, because it's a 16 volt cap bank. And then I want to let it run to the point where the spin isn't that great. And then I want to turn on the charge,
Okay.
which is on right now. I'm going to turn that off. And yeah, we will set up a relay that is timed to turn that on, and then turn it off, like 30-second interval.
Okay.
Maybe like 30 seconds on and 2 minutes off. Something like that. It's got to be off a lot longer than it's on.
And
Or we're going to blow everything up.
right, and that'll be the algorithm that we create for it.
Yeah.
Yep. Piece of it. Awesome, dude. Yeah, keep going. This is awesome.
Yeah. So, yeah, I wish I had juice in this multimeter right here.
Oh yeah, I got the cord plugged into the phone, guys. Sorry.
It likes to spin it very fast. So 11.94.
We got some juice. And that's out of which battery?
This one, the one that we're doing right now.
Yep.
And that's okay. When you do the BEMF, look at the meter.
He's making contact now. Oh wow, yeah, it drains it quick. So it goes from the battery to the cap.
Straight to the cap from the battery.
Okay.
And so now I have to turn the charger back on. That's got to charge up a little bit.
To be above 12.
Oh, but it's...
Oh, it's
Yeah.
about to die?
Yeah, it's dead.
Okay. Sorry, guys.
But I had to see like where the battery was. And see, it is charging just by running currently. It's just, this motor is now spinning faster than it's charging.
Got it.
And that's okay. I don't mind. I love the way it's running, and that's fine with me. It's spinning a little bit too much for it to ever be a closed loop right now. But the talk bubble closed loop can handle it no problem. And it's virtually just you. It's like an emoji. You know, you got your little comma, and the power is connected to the other end of that comma, and you got your loop.
I'm gonna zoom in on that. Move your hand real quick.
Talk bubble.
And then the comma, in terms of this setup, is this cap right here,
That's right.
and the yellow lead.
So everything on the vast side of the comma, like on this side, the side that doesn't have the loop on it, is everything else. Okay? Everything else, man. Everything that isn't on these two tables is the comma. And this is just where the transition takes place. This is the comma. This is the part that connects to the loop. But basically, by having it not connected to anything on this side, means that it's connected to everything on this side.
Thank you for the likes.
When it's vague like that, it means that it's everything. It's not nothing. It's all this is on the other side of that comma. All these batteries, all this power supply, all the signal generator is on the other side of the comma.
Right. That's a nice shot. It's shimmering on the magnets.
Nice. Alright, so, and I had to put one of these Schottky diodes in here, one of these fat diodes, for the BEMF, because the little ones kept, smoking. They kept burning up.
Mm-hmm.
Heck yeah, man, we're about to hit 9 volts. Like I said, I want to get this up to like 15. But I think that wheel's going to be spinning really fast at 15. Now see, with all that juice flowing through there, I don't know how long these clips will hold up. So I'm going to stop it. I'm expecting to see smoke one of these times, I'm just saying.
Mm-hmm.
Eleven, 9, 5, 6. Alright, so it's charging. That's sweet.
And that's because this guy's on.
Yep. With the signal generator. And because it's below 12 volts, it's taking a hot minute for it to charge.
And it is on low bat, so I'm trying to get good data here.
But I was spending. I was spending hardcore.
Mm-hmm.
Oh,
What do we got?
nothing. I thought it was trying to go up, but it was just going down really slow.
And that's because we removed the green clip from the diode.
Mm-hmm.
The battery from the cap.
Right on. Alright, let's try and get it up again. You okay?
Yeah, I can't get a good shot with you standing there.
Okay. Well, let me move over. It is hot. Maybe I'll turn the air on in a second.
All right, it's going up slow. Yeah.
Yeah, take it out. We gotta let the battery charge. It's obvious that the battery had drained
To a point.
to a point.
Got it. So there is a Goldilocks zone here too.
Yeah, absolutely. And I guess, like to narrow that down specifically to the touch, we need an Arduino. Very nicely calibrated Arduino.
And that
measure when it gets to that point.
Yeah, dude, that would be an amazing.
And then turn it on.
3,600 views. Thank you all so much for dropping in. Like and subscribe. Let us know if you have any comments.
I love how fast that's moving. Wow.
Yeah, man, this is a little mesmerizing. Get the full edge of the batteries there too. And these batteries are sticking out from the rotor.
Magnets.
These magnets. Thank you, sir.
You're welcome. That'd be awesome if we had the batteries sticking out, because then we could put the coils on the rotor.
Yeah, straight up. Welcome in, George. Thanks for dropping in. Like and subscribe. Let us know if you have any comments. We are working with pulse motors this evening.
The whole system is a secondary system. And it's running like a champ, man. It is not running like a secondary system.
Mm-hmm. That's right, because it's all coming from that coil, which is being fed by that rotor in that system. Or part of the same system. It's all part of the same system.
Mm-hmm.
Because of all these wires.
There's actually, yeah, a lot of wires.
Thank you, George. Appreciate you. You said awesome work.
Thank you. So we got the Halbach array going on the rotor right now. All the magnets are like a swastika with the north and the south. You get what I'm saying? They go like this. I mean, I think that's what the Halbach actually is when you draw it. That's how you draw it. So, very cool.
So what is it that you do?
Me, I'm a full-time dad.
Yep, stay-at-home dad. And having fun doing experimentation.
Yeah, I love doing this stuff. I'm not one to, if I'm running with the crowd, I'm actually kind of running off in right field by myself, kind of looking at the crowd and they're looking at me, kind of thing, man. I like doing my own thing.
All right, he said no. What's that? What kind of experiment?
What's this? Well, I don't know, man. I feel like you got to hear the whole thing, man. I don't.
He did just come in.
Okay. Like, now I gotta take a moment.
No problem.
All right. So this is called talk bubble closed loop.
Here's the schematic of what we're working with.
This is the stem cell schematic of what we're doing, subject to change.
Notice the accent and attitude on his lips because he's gotten so much guff.
Very much. And it's not even about the drawing, it's about not having a drawing.
Mm-hmm.
So, yeah, this is about as clean as it can get. So this half, this right here, is one of these coils right here. This side is these two tables right here.
And these are pulse motors, and we are working with electromagnetism experimentations.
Electromagnetism, experimentation,
Math. Note.
math.
Math.
Absolutely, man. You can't do this without doing some math. And you don't even really have to do the math. The math kind of does itself.
He says, "Oh, nice." And he
So
says, "I see."
This right here is all of that.
All right, let me get it. Let me get that, and then point at that again when I zoom out.
Right there.
Okay.
So this is virtually that. That is this 4 times over. Okay?
Yep, I see that. Yep.
And then this is what one of those.
Move your hand. I can't see it. And then let me know when you're going to point.
I'm going to point right now.
What are you pointing?
The big
Point
coil
on the
right
paper
there.
first.
I think I got to do it the other way around. So
All right.
adjust.
All right. Now I'm zoomed out. Go ahead.
All right. So this coil right here is running the thing on these two tables by alone. It's running that alone. It's connected to this battery right here. And
Now hold on. I got to zoom in. Okay.
That's this right here.
Okay.
And it's subject to change. So I've redone this 400 times since I've drawn this picture.
Yes. Says
But it's a stem cell, so it's virtually just, the most basic torque loop that you can build, and then you just change it. So I got the trigger coil running it now instead of having 2 coils and the switch.
And what's the difference between those?
Well, the transistor is used to switch with the trigger coil.
There's the transistor.
And it's a lot smoother. It's a lot faster. It's not direct electric though. It's not raw electric. It's definitely the more resistance, the proper amount of resistance, the better this is going to work. The transistor. Now, the switch is just a paper clip and a piece of copper.
Homemade.
Ding, 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 and this is how it works. You get it in there and you hear it.
Oh yeah.
And that's basically how it works. It bangs the paper clip up against the copper piece when the magnet passes, and voila, you get your reaction.
Thank you for the likes. I love those switches, man.
Me too.
Welcome in, Jose Luis.
When you need a good fix, when you need something to spin, and you just wake up in the morning and all your transistors are blown, you bust out your homemade switch and you're good to go.
Yeah. That's right, and you've made many of homemade switch in different sizes and shapes of different things.
Let's see where we're at, if you can. 1206.
1206 on the battery on the left.
All right, so Get a little bit more juice in the cat bank.
Right on. Right on, George. Thank you.
So that BEMF coming off of that big coil is phenomenal. It's like shorting a coil. It's like straight up energy straight from the battery almost.
And then can you not use jargon? So BEMF is what?
It's back electromagnetic field.
Okay.
And what that is the collapse, I believe, from the coil after the energy leaves it, when the switch switches off. The collapse comes down and forces out a spike of voltage that can reach 600, right around there, depending, really.
Thank you, George. Appreciate you. Thank you for your service. Be safe out there tonight.
Thank you, thank you. So,
Awesome explanation.
so what you do to get it is you hook up a diode parallel to your coil that you're going to be getting the BEMF from. So that's right here. And the negative is on this one is the negative. The negative is 6 over here, and then the red one is the positive, and positive is 1. And then the negative, which is the way the energy flows out, is also connected now to the cap bank. So you click on this to seal up the BEMF loop, and then this yellow one is clipped to the negative side, so it goes straight to the cap bank. It's the only direction that it can go in that loop.
Yanni's back.
What's up, Yanni?
He says, I came back at the right time.
Yes, sir.
BEMF. The electric creates magnetic and will switch back like a water wave. EMF is electromotive force. Or is that what it is? Or are you just you put a LOL there? Because I always thought it was electromagnetic field.
It is.
Okay.
It's both.
It's both. Okay. That's yeah. We like when you go to school for these things, you know, exact for sure. But we're in our own school here, guys, and Yanni has been a major help over the time. We appreciate you.
All right, so I'm just connecting the BEMF, and look at how much faster the rotor is going now at 9 volts, and it was just going at 8. I love trigger coils, man. And as you can see, I had the Hall effect hooked up. I had multiple different reed switches hooked up. I had my old switch hooked up, and the trigger coil wins hands down.
Straight up.
Especially for the way it's hooked up. Like the way it's hooked up, it has to be the trigger coil.
Yeah, we appreciate you guys so much. Like and subscribe. Let us know if you have any comments. We have a bunch of awesome pulse motor content and learning along the way. So if you guys want to start your own hobbies at home, this is a great community.
Heck yeah, man. Yeah, I learned everything I learned about all this electromagnetic, electromotive, all of it from the community.
So would electromotive force be equivalent to carbonic acid when we're talking about CO2? Is it just an archaic way of saying it, or is it the actual thing? Or like we say, burgled instead of robbed. You know, is it one of those things?
No, I think they're actually different things, but
Okay,
you definitely use the same acronym for both of them.
got it. Okay.
And I do think the force is the actual description of what's happening.
Society is in the house.
What's up, society? How's it going? Wow, man. Woo!
Because I, the cameraman, am making a good effort to, learn more about all of this. Because it is very interesting to me. Alex, can you translate that? I don't think I can do that on my phone.
See, now I had big magnets hooked up to this with my switch. It was going so fast that it threw a magnet and broke the first switch. It's like it threw a magnet and everything just whoosh.
Oh yeah, you were talking. That was today.
That was 2 days ago.
And it was just.
Yeah,
They
like
fly.
the magnet went that way and everything else went this way.
Oh no.
And the switch like snapped, so I had to build another one.
Art.
That's the sculpted peaks. I could try, before I stopped painting, I was making myself do a national wonder, world wonder, one of those, a natural wonder.
A natural wonder of the world.
Yeah, every time I painted, I was trying to paint, something more real than what I normally do. Wow, man. Trigger coil for the win.
What's up, society?
Need to grill myself a dummy.
The Shin Buster 9000. It's a little higher than the Shins. I'd say it busts some femur for sure.
The Sack Splitter 8000.
Welcome to the channel, everybody. Thanks for dropping in. Like and subscribe. Let us know if you have any comments.
I guarantee that's going to hurt more than being flicked.
Oh, yeah.
But a flick, I guarantee, man, there's lots of force.
Yeah, that can do some damage.
In that finger.
6,000 views. Thank you guys so much for coming in. We appreciate it.
This one, I call this one Sex on the Beach.
Wow.
And if you've seen it already, maybe you haven't seen it. There's the knee, and there's the back, the ass in the back, and there's the shoulders. But it's called Sex on the Beach. And
Okay.
get it?
Okay.
Yeah.
There's just random body parts with some sand. I love it.
And no, I didn't paint it like that. It just ended up that way.
That's the best.
Yeah, it is the best when it just ends up good,
Mm-hmm.
and you don't really plan it out that way.
Yeah.
It's like, oh man, somebody's on my side. It might appear sometimes that you are all alone, but it is in this time that you know, your bravery will shine.
We got a new name for it, the Nut Knocker 2.0.
Nut Knocker 2.0, that's great.
Love it.
That has many practical uses.
Practical applications, yes.
Yeah, just like your AR-15.
Mm.
Plenty of practical applications. Sorry. Yeah, it just reminded me of a really bad video that I saw.
Oh, okay, on YouTube.
Yeah, it was terrible. There is one use for heavy artillery like that. One practical purpose. And that's to kill people. And that's just not cool. All right. So yeah, I greatly and sincerely have to take a minute. And I don't know. Honestly, I don't know how the Nutcracker 2000 got me down on a tangent. I don't know how that happened. That was really funny. All right, so there's a lot of 1, 2, 3 applications going on right here. And 1, 2, 3. Like, for example, this circuit down here running this pulse motor is a 1, 2, 3. It has one connection to the base. It has 2 connections to the collector. And it has 3 connections to the emitter. 1, 2, 3. Bam! And this is what you get with 1, 2, 3. Awesomeness. It is a Bedini type circuit. And it changes. If you add the output, you now have a 1, 3, 4. Okay, you got 1 connection to your base, you got 3 connections to your collector, and you got 4 connections to your emitter. But you have output now, which is almost equivalent to the amount of energy going in.
Later, Yanni. Thanks for dropping in again. Society said yes, very practical indeed.
All right, so what I wanted to do to expand this a little bit further was to take the trigger, okay, let me explain this real quick, and it's how I'm able to put 12 volts in a 16 gauge coil. Okay, so I got the 16 gauge wound in series with the 20 gauge in this coil. And then I got the 22 gauge hooked up to this SSG with the trigger strand, which is a 30 gauge hooked up also to the SSG. So I want to get that SSG going and have that power output put in the comma cap bank. That's basically it. And then this would be, you know, you put it on a plastic lunchbox and you sell it. Bam. All right, I think I'm going to switch this off. And this. Oh, that's so cool. Another thing that I might want to do find a way to incorporate my little pancake coil into this hodgepodge somehow. And I think that'll be just fine. So what are we at? What are we doing? We good?
We're at an hour and 20 minutes. That's a nice. I mean, and we got 48 people watching, so we're rocking and rolling. Thank you everybody for joining in. Like and subscribe. Let us know if you have any comments.
And subscribe.
Do some Elvis, yeah. Thank you very much.
Thank you very much. Do the stiff upper lip instead of just the one.
God, yeah.
like you know, AC/DC. It's all right, man. We've come to a wonderful natural wall in the excitement, and I think that try and keep it nice and clean.
Yeah, those are good times too.
Yeah, we're gonna keep it nice and clean from now on, or we're gonna attempt to. I mean, we're not perfect, but thank you very much. Peace out. Have a wonderful night. Please subscribe. Join up. And have a wonderful day.